Alright folks, here it is, the demonstration of how to do motion detection, displaying that motion, and tracking the value of that motion. I'm going to start with the demo code called Motion Display that's on web courses and walk you through this. And the important thing to realize about how most motion detection and motion tracking works is through this process called background subtraction. And what you're doing is you're taking two frames from a video feed, the current frame and the last frame, and you're comparing them pixel by pixel to see what is different. If something is different from one pixel to the next, it usually means one of two things. Either that pixel moved, or the object that was that pixel has moved, or the light of that pixel has changed. So an interesting side effect of using background subtraction is it also tracks changes in light. So something can either move, and it will notice that, or if the light level changes, like if there's a lamp in the camera's view and you turn that lamp on, it will know that that lamp got turned on as well. Alright, so what do we have here? First, we're going to import our video library, and then we need a few global variables. Our capture cam is the camera feed, right? So this is the one that's coming from the library, which is why it's not orange. And then I'm going to make two P images. One is going to be a place to store the last frame, and one is going to be a place to store those motion pixels. I want to store the pixels that change from the last frame to the current frame, and I'm going to store them in a separate image called motion. Then I'm going to have a threshold, an integer variable called threshold, and I'm going to set it to a default value of 40. We need a threshold because given the quality of web cameras, particularly the ones that do autofocus and auto exposure, they're usually pretty noisy, and so the camera will think pixels are changing when actually nothing in our frame has changed because it's constantly adjusting the focus and exposure a little bit. So we actually need to look, we want to see if they change enough, right? And so we can have a threshold, and by making it a variable, we can change that threshold easily to, if we want to make it finer, so it's going to be filtering out less static, or grosser, so you need larger motions to trigger it. In our setup, I'm setting the size to 640 by 360. I've got to initialize my camera object. So I say cam equals new capture, which is this class of object. We give it itself, and then I'm going to give it the width and the height of the camera resolution is what I need to put in here. And I know that this camera can do 640 by 360 resolution, so I'm using the canvas width and height here. I could just as easily have typed in 640 by 360 there. And then the last one is the frame rate. You can see that right here. Like our audio input, we need to start the camera. So we do camera.start, and that's what turns the web camera on or gives power to it. And I'm going to initiate these two images, my last frame image and my motion image. And I'm going to just create images for both of them, same width and height of the canvas, and set those to RGB. So those, after this command happens, those are just blank images. In the draw function, something really important I'm doing is almost everything in my draw is going to be within this if cam.available is true. And I want to check that because while I do cam start here in the setup, that process actually takes a few seconds. So when my draw function starts, the camera isn't actually going to be ready for me to read information from it. It's going to take a bit of time. So I don't want to try to read data from the camera until it's ready. So if I wait and say if the camera is actually available, then I can read from it. If I try to read from the camera before it's available, it won't work. So after I check that the camera is available, I do cam.read, and what that does is it captures one frame from the camera and puts it in this cam variable. Now the cam variable is of type capture. It's not a P image, but it works very similar to a P image. So I can, for instance, say cam.loadPixels, and that will give me the array of all the color values in that frame, or what is now basically an image. I also want to load the pixels for my last frame image and my motion image so that I can access and have read-write access to all of those 3-pixel arrays. Once I've got all that loaded, I'm going to start looping through my array, and I'm going to base the loop off of the camera image since it's like the most important one. So I do for in I equals 0, well I is less than cam.pixels.length, and then I'm going to increment I by 1 each time. Now, this is where the threshold comes into play. I want to check the brightness of all of my pixels. And that's a simple way for me to check if something has changed from one to the other. So I'm not comparing individually the red value to the red value, the green value to the green value, the blue value to the blue value. I could do that, but it's easier and faster to work with the image as grayscale, which is what checking the brightness does. So I'm going to say if the brightness of the cam pixel at location I plus the threshold is less than the brightness of the last frame .pixel I, or 2 bars. This is the key that's usually above your enter key on the keyboard. That means or the brightness of the cam pixel at I minus the threshold is greater than the brightness of the last frame .pixels. Then I'm going to do something, right? So I'm saying if the difference between these 2 pixels is within our threshold, that means there's motion. So I'm comparing the current pixel to the last frame. So the first time through this loop, last frame is blank, it's black, there's no content in it, so almost certainly everything is going to be classified as motion, but then the next time through, that will not be the case. So, if this condition is true or this condition is true, it's going to go into here. And so what I want to say then is my motion image, set the current pixel of that image to the camera pixel. So I'm copying that pixel that's different from the camera to my motion image. Otherwise, if it's not in this range, if it hasn't moved, set the color to black. Then, regardless of whether there's motion on that pixel or not, I want to set the last frame of the current pixel, or the current pixel of the last frame, make that equal the current pixel of the camera. So in this way, my last frame image is always going to be the same as the last frame of the camera. So when I get a new camera frame, it'll be different from this one. And so then that is the end of my for loop. Now, I'm going to update my motion pixels because that's the only one I'm going to look at. I'm then going to draw that image using the image command, place the motion image at coordinate 0, 0. So I'm only going to see the motion. And then this else I have in here is going back to the is the camera available, right? And then I've commented out here just to check that, print line camera not available, right? So it'll let me know if the camera's not available. And that's it for my drawing. So let's run this and see what happens. Okay, so you saw that flicker there, which was that initial everything's moving because everything is not black. And now you're seeing only the things that are moving in the frame. So if I move my head, you're getting this kind of outlining effect, right? So even though my whole face is moving, these pixels, like in my forehead here, are close enough together in color that it's not detecting that they're moving. But the difference between like my hair and the background, though, is different enough, and so we're getting that edge between me and the background. Okay, so that's how we detect motion. Now, that by itself isn't that useful to us actually, because what are we going to do with that besides show this motion image? So what I also want to do to actually quantify the motion is then count how many pixels are going into that motion image, right? So before my loop, I'm going to make a long called motion val. I'm going to set it equal to 0. Now a long is basically an integer with more memory space, so it can hold a larger number. Then, in my loop and in my motion detection if, where I'm comparing pixels, if there's motion, then I want to increase my motion val by 1, motion val plus plus. So that's like saying, okay, this pixel, add that pixel to the quantity of motion I have. Right? And so then down here, I'm going to print out how much motion I have. So I'm just going to say print line motion val. Now the other important thing I have to do here though is just check it. So let's see what happens. Okay, so when not much is moving in the frame, we've got a low number of pixels that are moving. But if as soon as I start moving my head, we get several thousand moving pixels, right? Okay, well what if we want to use that information then for like a color, right? Then I just have to do some mapping. So I'm going to say float I'm going to call it motion gray because we're going to use it as a gray value. And it's going to equal the map of my motion val, so it's going to take that as input. I know that motion val is going to be between 0, there's no motion, or maximum possible motion would be every single pixel in the frame is different, right? So what is that? That's cam.pixels.length. So that's the upper extreme of my input range. And I only want as an output, I want something that's between 0 and 255. And so now instead of printing motion val, let's print motion gray and see what we get for that. Okay, much smaller number, right? 6 when I'm moving quite a bit, back to 0 when there's not a whole lot of motion. So then the last thing I could do is I might, instead of displaying that motion, right, maybe I want some element to change in response to this motion value. So I'm just going to say for this example, I'm going to make a rectangle at coordinate 0, 0 that covers the whole screen, width to height. And before I do that, I'm going to set my fill to motion gray. So now when I run this, I'm not going to see me, but if I wave in front of the camera, you can see I'm getting quite a bit of motion, almost up to 100 there, and the grayscale of my canvas is changing. So this is a great example of how you can get motion information from the camera and then get it into a workable value for your sketches.